try this problem. So if you're just sitting here messing with your phone, hopefully you're like, I know how to do this problem. Easy. Um, okay. In general, just like tomorrow on the test, you're like, I don't know what I'm doing. This right here is a really good place to start. It's not going to solve all your problems, but if you're clueless, that's a good place to start. Pick your initial final locations, make the lowest point you care about ground zero, identify what types of energies you have. Are you moving? Are you above ground zero? Okay. Um, if this, okay, this is not necessarily for this problem here. If you cancel stuff out, specifically if you cancel out work done by non-conservative force, if every expression has mass, you can cancel out the masses. Okay. Conceptually, what does that mean? Okay, so real quick warning, this work is not for this. I'm just using this as a, let's do this. If you can cancel out the masses, what that means is mass doesn't matter. Okay, it doesn't mean the object's massless. It just means if you had a big object or a small object, it's going to have the same result. Okay. Um, a popular error is if I give you some kind of force, some kind of non-conservative force, and I say calculate something, and then you just go straight away and plug force in for work done by your non-conservative force. And this is in newtons. This is going to be in joules. In order to make this work, you must multiply that by distance. Okay, that is a very popular error. People just stick in force straight away into work. You must multiply it by distance. Okay. One, one point of confusion. Oh, while I'm remembering this. Well, remind me to show you a conceptual question after I get done monologuing here. Number one, I tried to identify this as a thing. Make sure that you recognize when it's asking for the work done by an individual force versus the work done by all the forces, the total force, the net work. Okay. If you're not sure, ask. Okay. Now, this is equal to change in kinetic energy. The whole reason, big picture, the whole reason why we use or invented this idea of work is to show us how force affects the energy of something. Okay. If you're being asked to find the net work, you can come at it from two different points of view. You can come at it from the force times distance point of view, you can come at it from the change in kinetic energy point of view. Sometimes you've got both options. Other times I don't give you enough information to do it this way and you have to do it the change in kinetic energy way. Other times I don't give you enough information for changing kinetic energy and you have to use the net force times distance approach. Okay, so be flexible. Know that you can look at it from two different ways. Okay, good with that. Also recognize that the work done by your non-conservative force is just equal to your non-conservative force times distance. That's equal to change in mechanical energy. These two statements are different. They can be the same if the only force doing work is a non-conservative force. But this takes into account all the forces, conservative and non-conservative. This just takes into account non-conservative forces. Okay, so again, if there's a point of confusion, like, hey, what are you asking for? Please let me know. Another pitfall is to say that the change in energy is equal to the final amount of energy. Not necessarily. Okay. For case in point, if I give you $100 and you deposit that into your bank, do I know your ending balance? Nope. But I know your change. You increased $100. Do you see the difference there? Okay. So know that the change is not equal to the final. It's equal to final minus initial to find the change in anything. Okay. So watch out for that. This test happens to be more mathy. This unit is a more mathy. A lot of the concepts can be verified by doing math. So if you're a math kid, that's in your favor. If you're not, it's going to be a little harder. Okay. There are some concepts, though, that math isn't going to help you. One of which pretty sure I didn't show you this question. Give this one a shot. Talk to your neighbor.
But no, I would do the same thing. What? I love good win. And I see that as a win.
Okay, correct answer is C. Okay, this is the same concept as this. If mechanical energy is conserved, the path taken does not matter. Okay, good with that? So on this test tomorrow, it's gonna have like 2 to 3 show your work problems. Definitely some multiple choice. Maybe some explain stuff. No energy bar charts. Okay. So for this one, just real quick, you have the answer on your slides. Okay. But making this ground zero, initial, final. So for this one, you're starting at ground zero. There's still work done. You go, how fast is it going after? It's 100 meters. So you're still moving and you're above ground zero. Now, it's negative work being done. And it is friction times distance. Okay. You got to do friction times distance here. 1/2 mass times speed squared final plus mgh final. 100 meters. Does that go distance, height, both, or neither? 100 meters. Does that go into distance? Does that go into height? Both are 100, or neither of those are 100 meters? Distance. In order to find height, you need to do some trig to find that, the height. Good with that? Okay. So there is that.